Hello everyone. As part of the day 2, let's try to understand what is a container. Everybody provides a different definition for this. What is a container? For example, if you try to search in Docker official document, they will tell you what is a container. For example, if I go to Google Cloud, they will give one specific definition for what is a container, and then followed by Microsoft, IBM, Red Hat. They provide their own definitions for what is a container. Now, this becomes tricky for us to understand as a newcomers. You might be working as a development team, or you might be working as an operations, or you might be a fresher. Let me try to simplify that particular definition and let me present in this way. What is a container? Container is all about it has only libraries and binaries that needs an application and operating system to run. Technically, why we use a container? Inside the container, I want to run my application. That is the ultimate goal. If you look at the history of the compute, earlier we used to have a physical machine. After that, we have a virtualization. Now it is a containerization. In this containerization or virtualization or a physical machines, we are trying to run our applications. That is our final goal. In the same way, container also has application related and operating system related libraries and binaries without having any kernel. But there is a point to note. Container uses kernel functionalities of a virtual machine or a host operating system. Your container doesn't have any kernel, but you might have a question saying that if a container doesn't have any kernel, how my programs of the application can talk to the hardware? Because it is trying to use your underlying virtual operating system or host operating system. Virtual operating system in the sense what? It is an operating system running on the virtual machine. Host operating system in the sense the operating system which is running on the physical machine, or you can say a physical server. Depends upon the type what we are using. But I have simplified this particular definition so that everybody can understand what is a container. Same way you can answer in the interview as well. Let me explain once again. Container has only libraries and binaries. For what? That needs to run your application and operating system without having any kernel inside. This is a simple definition that we have to remember. Now, you understood what is a container as a definition point of view. Let us understand in detail about this by looking at this picture. I pulled this particular diagrams from Docker official document. On the right hand side, you can see virtualization. We call it as hypervisor. And on the left hand side, you can see containerization applications. If you look at the high level, we are trying to run our application. That is a simple way to understand. Don't make yourself complex to understand the concept. Here, we have underlying infrastructure on both the sides you can see. And then on the right hand side, we can see there is a hypervisor. What is a hypervisor? Then you might have a question. Hypervisor is a piece of software which manages virtual machines on top of the physical machine or a server. If I need to create a virtual machine like this, I need to have a hypervisor. In that hypervisor, again, we have two types. I'm not talking about that. For now, it is a type 2 hypervisor. This type 2 hypervisor will help you to create a virtual machine so that you can run your own operating system. In this virtual machine, I can run one specific operating system as per my requirement. Here I can run another operating system and so on. In this way, we can create multiple virtual machines and then we can run individual operating system. Not only that, it will allocate some amount of the hardware to that virtual machine. It will have its own CPU, memory, disk, network, and other details of the hardware that will be assigned to this virtual machine. So what are the limit we have assigned? Until then, the resource will be utilized by the application and the operating system running on it. That's a simple way to understand why we have to use a hypervisor in order to create a virtual machines. Now, what is a containerization? Containerization, if you want to implement it, whether you take a Docker tool or containerd, LXC or Rocket containers, Creo, you take any type of tool to create a container. Without having operating system, we cannot install them. Example, you can see Docker. If I need to install Docker engine, first we need to have an operating system on the infrastructure. And then only we can run our tool, and then we can create a containers to run the application. That's a basic difference between these two. But technically, if you want to explain someone or in the interview, what is the difference between containerization and virtualization? Let me tell you a simple definition. Container virtualizes the underlying operating system. What does it mean? In my point of view, how I can understand this? Your operating system is getting virtualized, not the hardware. What does it mean? For this container, it will utilize some CPU, memory, and the network. And this container will also do the same thing, and followed by all the containers. The containers on the system will use only the resource what is needed. Whereas in virtual machine, what are the resource we have allocated, it may or may not use. And your application which you are running on inside it, maybe the resource what you have allocated is not entirely used by your application. Some amount of the resource what you have allocated will be used by the operating system, especially the kernel. The rest of the resources will be used by your virtual machine application. That's a basic difference what we have between the containers and the virtual machines. In the container, it doesn't have any kernel. So what are the resources you have allocated to the container will be used only by your application. So that the containers are called as lightweight. We'll talk about that in detail. And for now, we need to understand that container virtualizes the underlying operating system. So it will segregate, and that resource will be allocated to only that specific application. What about hypervisor? Hypervisor virtualizes the underlying hardware. You are isolating the hardware and you are giving it to the virtual machines. Here we are not isolating the hardware. We are isolating the operating system resources like CPU, memory, disk, and then other computes that we are trying to virtualize. So this is a simple definition to understand what is the difference between containerization and virtualization. I hope this will give you some more picture about it. Now, let's try to understand why we have to go for container. A simple thing is container are used to build, to share, and to run your application. What is meant by build? You as a developer, you will be writing some particular program and everything, whatever is needed for application software, and you will compile it. In this particular build process, you will write some particular code, and then you will build an image, because without having an image, we can't create a container. Image is a reference to a container. How we have an ISO, right? Without having ISO, we cannot install the operating system on the virtual machine or on the physical machine. That is a reference for it. And in the similar way, image is a compiled bundle. It is a compiled one. That is called as build process. Once a build was done, I can share this particular containers between multiple platforms. It doesn't mean that I built the image by using Docker. Can I run it on the cloud environment? Yes, we can. Can I run it on Windows operating system? Yes, I can. It doesn't matter. Unless your specifications of the image has been changed. But once you have built the image to launch your container, I can share it anywhere. That is meant by shipment. And then finally, we have to deploy. What is meant by run? Deploying a container to run your application. So development, shipment, and then deployment. These are the 3 points that you need to remember why we have to go for containerization technology. In a simple way. Further, let me try to explain what are the key benefits we have in containers, especially lightweight. The container will have only the libraries and the binaries which are related to your application and the operating system. It doesn't have anything else. That's the reason those containers are lightweight in nature. And next point, portability. Portability in the sense what? Today I have a Windows operating system. On that, for example, I installed a Docker desktop. I built an image and I'm running my container. Now, by using the same image or the same container, can I migrate it to another platform where I have a Linux operating system? There I'm using Docker Engine instead of Docker Desktop. Can I run the container over there? Yes, you can. That's a portability what we have. And especially if you talk about Docker, Docker can be installed on different operating systems like Mac, Windows, Unix, and Linux. That's a flexibility what we have. And then what is another benefit? We have scalability. For example, if I want to stop, if I want to start, or if I want to increase the number of containers based on my load on the application, or if I want to decrease, which is called as scale in, scale out, I can do it within seconds because the containers are lightweight. It doesn't take much time to provision when you compare with the virtual machines. To provision the virtual machine, it will take some time because it has to boot and then it has to run all the services and then your application will be ready. But here, the containers will get started within seconds. If you take a simple Nginx container. So scalability is all about the flexibility what we have to increase the number of containers or to decrease the number of containers. The technical words are scale in and scale out. And then we have security. What is the security? Which means though you are trying to run all the containers on a single platform and where your underlying operating system is getting virtualized, it doesn't mean that there is no security. Containerization is using a technology called Linux kernel namespaces and C groups. Because of that particular features what we have, it is more secured so that one container cannot see the resources utilized by another container. Everything is isolated. That's the security what we have in the containers. And then finally, agility. Agility is all about in today's SDLC process, that is software development lifecycle. We have adopted DevOps culture, DevSecOps culture, right, in the organizations. Now, you are collaborating your developers and operations team together to use a common platform to develop the applications, to run the applications. Now, what this container will do, this will fill the gap between the developers and the operations team so that he will build the image. That image he will test it in his local system or his dev environment or a testing environment. It will work. Then that image, if I try to pull it to the production and I should able to run the container, that is a gap what it is going to fill when you are using the containerization technology. So these are the key factors what we have, why we have to go for containerization. I hope these points will help you a lot to understand the basic level of what is a container and why we have to go for container. Thank you.